Good day. Welcome back to our second lesson on grade 12 inverse functions. In the first lesson, we looked at the inverse of the linear function or the straight line. In this lesson, we're going to focus on the inverse of the quadratic function, or also called the parabola. Let's look at this problem. In this example, they say that there's a function given, y equal to 3x squared. Now, you will recognize this as a parabola, and we call it the happy face parabola, and the turning point will be at 0, 0 because it's only the square term. And then they ask us to find the equation of the inverse. So we're going to do it exactly the same way as what we did with the straight line graph. So I'm going to say that in the function that is given to us is y equal to 3x squared. And you still remember that for inverse, we always swap x and y. So we say for inverse, we write it as x equal to 3y squared. So we substitute y with x and x with y. And now we need to manipulate that. So we will get 3y squared is equal to x. So that means that y squared is equal to x over 3. So therefore, y will be equal to plus or minus, because we find the square root on both sides, of x over 3. This inverse is not a function, but that we will discuss in lessons to come. So let's look at the second part of this question. They say that we need to sketch this function, this parabola, as well as the inverse on the same set of axes. And we also need to show the line of symmetry like we did. And you remember that line of symmetry we said is the line y equal to x. So let's just do that quickly. We're going to find 3 points on the parabola y equal to 3x squared. And the first point, I'm going to start with x as minus 1. Then I'm going to look at x equal to 0. And then when x is equal to positive 1. And we're going to work out the corresponding y values. So when x is minus 1, and I substitute it in, because I square it, I will get positive 1 times 3, and your answer will be 3. If x is 0, then y is 0. And when x is 1, 1 squared is 1 times by 3, and that will be 3. When we look at the inverse function, y equal to plus minus the square root of x over 3, we don't need to calculate these 3 points again. We may just swap them around, because x becomes y and y becomes x. So always remember with inverse, if you have a coordinate or on the function, you swap the x and y, and that will give you a point on the inverse. So this point will be 3 and minus 1, 0, 0, and 3, 1. So we're going to plot these points now on the grid. I'm going to start with the parabola. And they say to us that at minus 1, that is minus 1, and 3, that is 1, 2, 3. At minus 1 and 3, there's a point on the parabola. At 0, 0, we find a point. And then at 1 and positive 3, we also have a point. And you can now see where this parabola will be. So we're going to draw this parabola right through this minus 1, 3. It will turn at 0, 0, and it will go up and intersect that point of 1, 3. So let's just quickly draw that graph. So as you can see now, that is the drawing of the parabola which is y equal to 3x squared. Now I'm going to plot the points for the inverse, and they are the points x equal to 3 and y is equal to -1. So the first point is right there at x equal to 3 and y equal to -1. Then 0, 0, and then at 3 and +1. And now we're going to draw that graph. As you can see now, this is the inverse of this parabola. So our parabola with the inverse, our inverse, and that is why I said in number A that this inverse is not a function. Because you still remember, to test for a function, we do a vertical line test, and if it cuts more than once, it is not a function, but that we will discuss at a later stage. The last thing we need to do in this question is to draw the line of symmetry, and that line of symmetry is going right through the center because it's the line y equal to x, and it will intersect right there where the two parabolas intersect, and it will go up there. So I'm just quickly going to draw that line. As you can see now, I did the drawing of the line of symmetry, and always remember to write down the equation. That is the line y equal to x. The parabola was also given to us. That equation is y equal to 3x squared. And then we also have the equation of the inverse, and that is y equal to plus minus the square root of x over 3. Just important, you will notice that I did not write this final answer in fx notation because this is not a function. We can only use that notation if we are working with functions. So let's look at our next problem. In this example, there's a function given to us, a parabola again, but please take note that this one's got a negative orientation. So that means that is a sad face parabola. And they ask us to find the equation of the inverse. So let's just do that again. So we're going to say that this is the function, which is y equal to minus 2x squared. And then the inverse is where we swap the x and the y. So we say x is equal to minus 2y squared. And now we need to find y. So we can now say that y squared is equal to negative x over 2. I divide it with that negative 2 on both sides. And then we find the square root on both sides. So y is equal to, and that's why we put down the plus minus, and we get negative x over 2. So that is my inverse of the parabola. Like I said before, this is not a function, so we can't call it the inverse function. The parabola is a function, but the inverse is not a function. And that is our inverse. In B, they ask us to sketch this parabola and the inverse again. And we're going to follow the same approach, and we're going to find 3 points. On the parabola, those points we're just going to interchange, and that will be the 3 points on the inverse. We're going to start with y equal to minus 2x squared. And again, we're going to take x as minus 1, x to be 0, and x to be positive 1. Now, when x is minus 1, and then when I square minus 1, I get 1 times negative 2. My y will be negative 2. If x is 0, y will be 0. And if x is 1, I also get negative 2. Now for the inverse, and this is now for this graph, y plus minus the square root of negative x over 2. We don't need to calculate these points again. We can just interchange them. So we say minus 2 and minus 1. This will stay 0, 0. And this will be minus 2 and 1. And now, like we did in the previous question, we're going to plot these points and we're going to draw the graphs. So let's just plot them. When the first point, I'm going to start with a parabola. When x is minus 1, that is minus 1, y will be at negative 2. So the point is right there. Then the turning point at 0, 0. And then we have 1 and 2. When x is 1, y will be negative 2. So this parabola is going right through those 3 points right there. That is where we're going to draw it. So let me just quickly draw that parabola. So there you can see the drawing of the parabola, and that is the graph y equal to negative 2x squared. And we just put that equation on the graphs to see which one is which. So let's just plot the points of the inverse, and that is when x is negative 2, y will be minus 1, and then 0, 0, and when x is negative 2, y will be equal to 1. So we're going to draw this inverse right here, and it's what we refer to as the sideways parabola. Important, it's not a function. So let's just draw that graph. So as you can see, this is now the drawing of the inverse of the parabola. Let's just write down the equation of this one, and that is y equal to plus minus the square root of negative x over 2. The last thing we need to do here is we need to draw the line of symmetry, and I think that you now know how to do it. It's the line y equal to x, and that is the line that goes right here. You will see that these two graphs intersect in 2 points, at 0, 0, as well as at that point. And this line of y equal to x is going to intersect at the same 2 points. So let's just draw that y equal to x line. So there you can see the line of symmetry. And this is the line y equal to x, my line of symmetry. That is always the line of symmetry when we are working with inverse. So let's look at the last part of this question. And in this question, they ask us to determine the coordinates of the points of intersection between the parabola and its inverse. Now, you will remember from the drawing that there are 2 points of intersection here. So we're going to get 2 answers. And we're going to use simultaneous equations to do this. And we're going to use the parabola. And that is now y equal to minus 2x squared. And we're going to solve it simultaneously with y equal to x. Like I said before, it's much easier if we solve the graph with y equal to x, because the points of intersection of the 2 graphs is also where y equal to x intersect. So we can now say that minus 2x squared is equal to x. Let's take it all to one side. So then we will get 2x squared plus x is equal to 0. Now we can take out a common factor of x, because this is a quadratic equation, which is what we expect because we need 2 answers, and a quadratic equation will give you 2 answers. So which will give us 2x plus 1 equal to 0. And now we can solve x. So x is 0 or x is negative a half. And because this is one of the graphs that we use to solve it. You can see that y is equal to x, so whenever we have x, we also know what y is. So that means that y will also be 0, or y will be minus a half. So now we can write down that our points of intersection will be the points 0, 0 and negative a half, negative a half. And with that, we are finished with the inverse of the parabola. Thank you.